So Archimedes' principle starts off, you have your buoyancy of your object in the density of the water times the volume displaced times the gravity. And basically when an object is floating, your buoyancy equals your weight of the object. So if you can find the weight of your object, you can set it equal to the information in the water of the buoyancy. And basically it's basic algebra from there, so you just solve for your height displaced, which is your water line on the boat. So our boat started off, we basically started trying to make a very thick bottom so water wouldn't erode it through. And then from there we tried to create more rigid sides using angles on each of the edges of the bottom, and then created walls going up just so it would be stiffer and more rigid. So taking a look at image 1, we noticed that their boat was fully watertight and all the edges were perfectly sealed together, which made it a lot easier for to get in and have it be sturdy. On image 2, we noticed that each person evenly had their weight distributed, with the 2 heaviest at each end and then the 1 lighter in the middle. And then on the 3rd image, we noticed that the thickness of the bottom of their boat helped to keep them afloat.
For our boat, the most effective part was the size of the boat. It could fit around 4 people and was easy to get into. This was good for when we tried to get into the boat. It didn't break instantly like other boats. The least effective part, or the part that we would change, was the overall structure of the boat. When we got into the boat, it was fine, but eventually, as we started to paddle, the seams that connected the walls to the floor of the boat started to open up, which was how our boat eventually sank.